Hi, Sportster Paul. We're here with SolidCAM. We're going to try to do this test part as fast as we can. So here's the SolidCAM tab, new part, milling part. And I'm learning. Make this short so maybe that tree doesn't keep pushing over. Internal, we want it internal. Nice short name. We want to do a coordinate system now. I want it in a vise like, come on, like this. So select a face, pick an origin, flip it around, Z. That's the way it sits in my machine. Accept all this, even though it causes problems later and there's no way to fix it that I found. Give it top setup. Say OK. Stock. I want to do it by stock size, the only rational way to do it. 4.5, 3.5. You can't even do this in CAMWorks. 1.5. I happen to know. Oh gosh. See, I'm rushing. I got to get what my mentor used to call a professional's tempo, because rushing isn't going to get it done. 0.4. So that's where we want the stock. Then add box to model. We're going to need that to change the origin because we got to move part 0 here. It's clumsy. All this front end stuff is clumsy, but not the end of the world. Go back to coordinate system. Remember to go edit. Remember to go edit again. Remember to select the same face, but now pick the origin here. Once again, you've got to flip it around twice. Okay. Then say accept. Same name, but now the stock won't be right. So all you have to do is go into stock and go out of stock. And then you can accept this, and I think everything should be where it is. Okay, there's the stock, everything's right. So first thing here, add milling operation, face. You don't select anything. This is the way MasterCAM, a lot of them work. Select a tool. You have to know to go to this mystery unlabeled button. You have to know to say SolidCAM Master Tools for aluminum. You have to know tool number 25. I've got it memorized. 1/4 inch carbide end mill, long enough to do the perimeter. You got to remember to do this, next free tool number. Then you can go over here and close it. Then you can accept it up here. I hope you can just see that. Levels. Upper level 0, I think that's right. Let's double check. There. 0, right. Face depth, this is right, but it's so nice. Visual Mill does this too. Technology, I don't like hatch. Let's do contour. I'm going to change this from the practice run I did. I think we might even be ready to go. Let's take a look. See, this is where it complains because of all that gibberish in the coordinate system. And it goes around. It should be climb milling. I think it's smart enough to know that. The name, face, top. And we can get out of this. Upper level, yes, face, top. See, this box keeps pushing over and keeps pushing over. Let's give it a little more room. Give it here. And, oh, this might be a trick. I double clicked on this once. It gives you this box. And I just said exit. No, I didn't double click on it. I said delete. Then it gives this box and say exit. Say delete. Exit. Well, it used to get shorter. Nothing ever the same with software. Twice. I think it would be deterministic. Okay, we got a face. And you can unclick here. Oh, and we can also get rid of, we're done, I think, with the hide this, suppress the stock box. So this is our part. Go back to the SolidWorks thing, or SolidCAM tree. Now we can go here, add milling operation, profile. The geometry, we're going to call this a perimeter. And we've learned from MasterCAM that you go here, so the arrow, and when you're on the left, it's climb milling. Say accept. Say accept. Tool. It never remembers the last tool, which is pretty exasperating. This part's designed for one main tool. Upper level, I think it's got this right. It is pretty intelligent, I have to admit. Yeah. So we don't want to just go down 1 inch, which is the bottom of the part. We want to go 1.02, so we undercut it a little. So when we face the bottom, there's not a sharp edge. Technology, left, that's good. I think all this is hunky-dory. Okay. Clear offset. We want to clear 0.125. And we want the step board. This is to get the tiny corners of the stock, 1.25. And then equal step down, rough, 0.125. I'm going to say no wall offset. I'm not sure I'm doing stuff right. Let's calculate a tool path. There they are. And see there's 2 of them. And that gets right here in the corners. And you can extend the entry exit here if you're worried about the tool coming down on the stock. That's here in the link. Lead in, lead out. You can move it a little. Let's see if we can do it. 0.5. Just lead ins and say tools. And did it seem to do that? Yeah. So now we won't be coming down on the edge of the stock. I want to super rush it. It has F, Y the loop adds little letters. I don't know. It inherits the name from the profile. Okay, so now we've got the profile. Let's do the pocket 2-wax. Once down to this level, then the shallow pocket here. Add milling operation, pocket. Geometry, add the geometry. We're going to call this deep pocket. And then the chain list, you got to remember to take off tangent, proposition, and constant Z both. And then same thing, you can pick here, and then you can just go accept, 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 all the way around. Gets 2 little ones right there. That's wonderful, worth its weight in gold. Knows it's got a chain, asks if it's okay. You're out of here. Tool, same tool, click, click, click. Levels, now we might have to teach it. The upper level, I think it was smart enough. It got that right. The pocket depth, though, it doesn't know what to do with that. So you give it a little help. It's got that. Technology, no offsets. Contour, none of this. I think, wall finish floor, I think this is actually done. Isn't a step down somewhere? Equal step down. See, everything's kind of in a different, it's in levels here. In contour, remember, it was somewhere else. And let's do a tool path and see. There they are. Real quick. Right? Just what I like to see. You can save, you can do, if this is save and copy this, which would inherit the tool. Let's just save and exit. Oh, it didn't. P for pocket, I guess. Let's get rid of that. Delete, delete, and save it. Okay, hide the tool path. Add machine operation, pocket. Do the geometry. This one is shallow pocket. This one's going to be clever. Same deal, take off tangent and here. Start at this part of the line. I assume it might do climb. Now you can accept with this one here, accept all the way around till you get to, let me move this so you can see what we're going to do. This is fantastic. This is my buddy Dave taught me, the guy who designed this part. Okay, now you do change direction. This one, go, change direction, go, change direction up. I know you got to do it once, otherwise it follows that line. So now it's back on the arc. Change direction, go down. Change direction, go over. Change direction, go up. Change direction, go, where we want it to go. Here, and now it should close. Yes. We gave it a new name. Everything is good. Tool, select, Just accept it. This 1/4" end mill's doing everything. Levels. See, upper level, see, it would do the whole top. It's because the geometry was starting at the top, but we know we want to start there, already down there. And the bottom, we want to go here. This is so civilized. Technology, I think all this stuff is cool. Levels, we might want to do 2 levels, which means, 0.1 or whatever. Let's see if we can do this. There they are. And, the fact that it snuck in here and did that, when we did 3D eye machining, we had trouble getting that to work right. So do we got a name? Not, it always adds a little to the because you might have one geometry that you use 5 different operations. I think we're okay. Shallow pocket. All right, oops, sorry. Okay. So now, let's go. We want to do this flat here. Dave showed me how to do that, and this is even cleaner than MasterCAM. Watch this. Add milling operation, profile. Just a simple profile. It's thinking for a bit. Geometry, and only, I don't know, maybe MasterCAM lets you do this. You go down here and say point to point. And the profile, let's see, we want to be on the left, so you go here and pick this point here. Draws that line. There's our arrow, so being on the left will make it, climb milling. You got to accept it here. Everything's a little confusing. Go here. Oh, I didn't name it. All right, well, that's life. Could we see? And if you go to edit it, it won't let you rename it. It's already in their data structure, so tough luck. Tough luck. And here, let's see, just accept the tool. Levels, top of target. Profile depth, I happen to know that's right. See, this is where you got to remember step downs. Oh, and you got to do clear offset because you don't just want to do one pass. And I happen to know 0.9 with 1/8 inch, 0.125. Go here. What are we? 12 minutes in. And that looks pretty good, right? So now we know this is the flat. And get out of this. Okay, so we got our flat. So we're rocking now. Add milling operation. Now we're into, this is still in the base package. There are 2 high-speed surfacing in the base package. And of course their dialog boxes are different. I think linear and constant Z. So we're going to stay here in linear. The geometry is pretty basic. You go here and here. Those 2 faces are what we want to do. The tool, and this was what was so clever. I was using a ball mill going across. Dave's like, no, you keep the square end end mill, but you don't go across it, you come down on it. I think, or is it, this step over is what we're going to want to tighten up, but let's go look at it, make sure it's doing what we want. Yep, see, happy days are here again. I did a trial run, I had this advanced. I'm not sure if that screwed it up or, be in simple mode seems to work. Now we're going to make it really fine. 0.1, 10,000th of an inch. I don't like these tall step overs. That, or clearance. I think that is in levels. Clearance area automatic. Change it to a plane. 0.2. Let's try that. It's kind of ridiculous, but okay. So everything seems okay. I'm not sure it'll crash or not. We'll see. And this is slopes. File, save all. SolidCAM, I crashed this once practicing because I did some goofy stuff. Now here's the money. This fantastic simulator. See, now it's doing the slopes. And when you do the compare function, everything on top is green. The side walls, that's within 1,000th, plus or minus 1,000th. And you can tighten these up and adjust it. I did have it crash once and all these colors went to purple. So then you got to go here and, recreate the default colors that they used. But this simulator, worth its weight in gold if you're going to do any 3D, any surfaces. All right, what's next? Operations. You can barely see it. Machine setup, not at the start, at the end of the, it's just off your screen, at end of operation tree. This is going to be bottom setup. And you go here, and we need a new coordinate system. And now you go add. And you select a face. We're going to have it in a vise like this, so this face. Pick the origin. I want it. Oops, that's a mistake. Pick the origin again. There. I'm doing this wrong. Get that little point. There we go. And Z is correct, so we go here, flip around Z once, twice. Now it's in the vise, fixed jaws in the back, the way you're supposed to. You have to make part 0 part of the part, or it won't be precisely the right height, right? And so I figure you find the parallel. We went through this in the slow shows. You got to accept all this. It's goofy. Now is our chance to rename when it comes up. Here we can say bottom set up. And don't say add. That's how we got here. Bottom setup, bottom setup. I think we're okay. By the way, up here is where you add fixtures for any given setup. I made that mistake. See, and you can't click there. You got to go way up here and click add milling operation, face. Don't select any geometry, but do select our tool. See how cool this part has been thought out, even though it tortures CAM systems. Levels, face depth, it's got that right, equal step down. Let's make it even number of step downs. Technology, I don't like hatch, I like contour. I'm a contour oriented guy. Let's go over here so you can watch it. Tool paths, always gives you that thing. Okay, there's our levels. It's going around. Life is good. Get it here and say face. 17 minutes. Bottom. Go out. I should have it under the headshot. I always like to go here. I always warned you. You can dismiss this, and I probably should have, but it just bothers me that it had to do with that whole bunch of gibberish after the coordinate system. So we faced the bottom. Now we're ready to center drill. So we can click here, add milling operation, drilling. Geometry. In my testing, it actually, unlike MasterCAM, it pays attention to the order. So I figure let's do the closest ones first as it sits in the vise. Don't pick the side, because then it has depth information. Oh, that didn't work out too good. I'm hitting the delete key. Okay. And see, it's going to do them in this order, which is just delightful. This is, let's not say drill, let's say holes. These are, the geometry is for the holes. We're going to keep reusing this. And I think it's happy. Tool, select. Now we're going to add our first tool. Where do you do that? I wish they'd label buttons. Good gosh. I don't know why it's easier for me to remember that kind of stuff. Center drills. 1/4 inch center drill, there it is. Remember to go here, next free tool number, and then you might not be able to see, but I'm going, just dismiss it. Then you got to go here and accept it. Levels, the upper level, I think it's got that right, 1 inch. Yes, the drill depth, we don't want to go down there. I happen to know from practicing and practicing, 0.25 is as deep as we want to go. I don't think there's that much else to worry about. Let's make the tool paths. There they are. Let's exit. We should exit and copy, but I'm going to re-click on this. And this is center drill. Center drills. And now we get out of it. Hide the tool path. Oh, let's do this so you can see a little better. Go up here. Okay. And drilling. Now this is the actual drill. I'm not going to chamfer like this is so goofy the way they, I don't know, maybe it's probably the way it has to be done. I'll be going back to Visual Mill after this practice and try how that works. What are we trying to do? Drills. Happen to know it's number 7. We got to go this direction. Number 7 carbide drill, 201. That's for cutting tap. For a rolling tap, it's a number 1. But next free tool number, we can close. Now we got our drill. Now we can accept that over here. Levels, upper level was 1. The drill depth, I happen to know, is I like leading zeros. That's how I was taught. 0.44. Even though SolidWorks defines it as 0.38, that's to the shank, or the flank of the drill. This does to the tip of the drill, and you gotta deal with all that. We'll show you why that's actually the right thing. I think PEC, I wish they'd, why am I calling out G-codes? I bought this program so I don't have to worry about G-codes. Once again, let's do our thing. No geometry selected. How about that? Geometry, and now you can just go holes. Now we're gonna do it. Zing, and notice it does them in the same order. With Master Cam, there was some goofy thing. This is, drills, and save out of it. So there's our drills. Hide that. Add milling operation. 21 minutes. We're doing pretty good. Drilling. Geometry. That same geometry. Holes. See, this all seemed complicated and clumsy to me until I used it for a while. Now we're going to have to make a new one. And it's got master library up here, and we go down. Taps, here they are. Taps 5, quarter 20, where is it? Quarter 20, I don't know what this STI is. No, that's a form tap. That would be a busted tap. We can use the stubby one. Excuse me, we're not going down very far. Pick it. Okay, so there's our tap, accept that. Levels, the upper level's right. The drill depth, I happen to know, to work out the best, to make a good point for you folks. 0 point, I think 4, let's go 4.0. Technology, drill, cycle type, G84, is that, can you peck a tap? I don't know. Let's leave it where it was. And hopefully, there they are. So, nominally done in 23 minutes. Excuse me. Here. Now let's do file, save all. I crashed it once. Let's do, this simulator is just so good. This program is, it's priced like Master Cam with modules, right? The basic program is less, about $5,000. You get a deal. What's going on? Okay, so this is the tap. Notice they modeled the taper of the tap, and you can play with that. And if you adjust that tool and go here, and then what convinced me that this program is worth its weight in gold, you can see with that 0.40, the tap doesn't quite go deep enough here. I mean, it's tapping, but it's not all the way through. And here, though, here's where it seems correct, right? Because it's not bottoming. This corner is where the drill is, the 0.201 drill. So now do compare. A tap looks like a gouge, right? It's red because SolidWorks models the tapped hole is a 0.201, but the tap is actually the outside edge of the threads. So all these programs show it as a gouge. But notice when we look at the holes, control, setting, even though they're 0.38 in SolidWorks, 0.38, by setting them to 0.44, the tap drill went, so it's green, the blind hole is green. You can't quite see this one, it's green. So that's the exact right length. It broke out here. But see, why this is worth its weight in gold, the simulator and the way they model the tap with the taper. And of course, you got to model the tap to match a real physical tap, bottoming, plug, normal. But you can see what's going on here exactly, and you can see what's going on here exactly, and you're not going to drive a tap into a bottom. So about 22 minutes with a couple minutes of enjoyment here. Let's close that. Do a file, save all again, save all. Let's do operations, simulate. Oh no, this is the conventional simulator. Operations, beta simulator. This is the baby. And we're pretty fast. So there's our facing. There's our perimeter. Here's the deep pocket. Here's the, oh no, it's steps on the deep pocket. Here's the shallow pocket. Here's the flat. Here's the slope. I think you can do this real time. Yeah, isn't that amazing? Compare function. Okay, flip it over, facing the bottom. This is more money than I want to spend, you know, because if you start getting 3D modules, bam, bam, bam. Huh? Okay, that's it. 26 minutes, and we even simulated, and of course it took longer to learn all this, and I practiced once and screwed it up, but that's SolidCAM as fast as I can make Dave Rui's test part. So good luck with your CAM stuff. We'll see you on the next show. Bye now.